I did that again. So besides inverse sine, another way that this can be explained or stated is by saying arc sine. So that's kind of a new term for you. Hello, good morning. Maya, I'll get you this. We haven't talked about it yet, but I'll explain here shortly. So arc sine is another way of saying inverse sine. So it's just some new vocabulary to become familiar with. So similarly, like as what we just looked at here, I want you to think about what we're actually doing when we're solving these, right? If we are asked and if we're given that the cosine of theta is equal to the square root of 2 over 2, then to solve and get theta by itself, we are taking that inverse cosine to undo that cosine there. So that means we are taking the inverse cosine of that particular angle, and then we would find what theta is equal to. Okay, so kind of keep that in the back of your mind. What I want you to notice in both of these sections, I'm actually going to cross some stuff out that I want you to cross out too. Just because we do not have to talk about this with your TI Inspire. This is something that happens kind of with other calculators. So you should be, if you notice this is asking what mode should you be in, you should be in degrees. I want you to notice the notation that I've used, because all of these, I'm using some different types of notation, but the process that you're going to go through on your calculator is exactly the same for all of these here. You're doing the inverse trig function in order to find your answer, right? So we'll talk about kind of the different notations here in just a second and how you would write answers for that. But try those on your calculators, plugging in to get those values. Let's go to let's go a couple places out on the decimal. So go probably 3 places out on the decimal. Okay, I think you guys are picking up on what the questions I'm hearing and the comments that I'm hearing from you guys. You're picking up on the fact that I've kind of written these in a little bit different notation, but remember what I said. For all of these, ultimately you are going to do the same thing. So this first one, it's just saying take the inverse sine of 0.88. So on that one, you should get that it's about 61.642 degrees. Did we get that? Okay. Even this one, this is similar to what I had up here, right? It's asking us to solve for that alpha. So we have to take the inverse cosine of that 0.23 in order to get our answer. So what did you get for that, Talia?
76.703 degrees.
Yep, there you go. 76.703 degrees. Sounds good. So this arc tan, if you don't like the arc business, then rewrite it as that tan -1 to remind you that you're taking the inverse. But arc means the same thing as inverse, which is not the same thing as reciprocal. So please be careful with that. All right, Zach, what would you get for this one?
For arctan?
Yep.
71.565
degrees. Sounds good. Sophia, what'd you get for this one? The y equals cosine.
145.085 degrees.
There we go, 0.085 degrees. Excellent. So notice like on that one, we had this y equals, so I wanted to write y equals as part of my answer there, okay? What I crossed out there, if you actually look at what it is, your graphing calculators, your TI Inspire has these inverse secant and inverse cotangent and inverse cosecant buttons. Most graphing calculators do not have that. And so you have to think through the process of how are you going to do that part of it, because they are reciprocals. That's the beauty of your TI Inspire. That's part of the reason why we chose these calculators, because it has a little bit more functionality on there. So you don't have to worry about that other part of what that's saying. You just have to see. Inverse secant of 6. What do we get for that, Dina?
80.400.
Okay. And Owen, for that next one, the inverse cosecant?
14.48.
Okay, sounds good. And this arc cotangent is going to be 22.62 degrees. And what about that last one, that inverse cotangent of 0? What did we get?
90.
I'm sorry?
90.
90 degrees. Okay. Awesome. Okay. Here goes. Now we are going to talk about finding inverses not using calculator, but using unit circle. Okay? And when we do this, so if we're just finding a single inverse, we are going to restrict we're going to restrict where we look on the unit circle for answers. So we're only going to look in particular quadrants. So part of what you have to understand is what this table is telling you. I will give you this table on a quiz or a test, but it helps to kind of understand what it is saying. And I'm going to explain it here, but I'm also going to kind of give you another visual to help you with thinking about where you're going to look for these answers as well. Okay? So if we are asked to find the inverse trig function of some value and the value is positive, then we know, if you notice, it's telling you any particular inverse, cosine, sine, tangent, secant, cosecant, cotangent, if the value is positive, then we're going to look in quadrant 1, which makes sense because if you think about it, we know that everything is positive in quadrant 1. So if we are looking for the inverse trig function of something positive, we're always going to look in quadrant 1. So the rest of this depends on where these trig functions are positive and negative. In general, kind of the guideline is that if values are positive, we're going to look in quadrant 1. And then if we are looking for the inverse of something negative, then we are going to look in quadrant 4. Now here's the issue. If we think about it, and you go back to your all students take calculus that I explained to you previously, if you think about it, what this is telling us is cosine values are positive in quadrant 4. So obviously we can't look for a negative cosine value in quadrant 4, so we're going to have to look elsewhere. Okay, so cosine and its reciprocal, instead, if it's negative, then we have to look up here in quadrant 2. And then, if you notice, I have a little asterisk next to this one. That's cosine and its reciprocal. There's always that exception to the rule, and the inverse cotangent of something negative, we also look in this quadrant, okay? So that's in general what the rule tells us, and that's what this chart is telling us too. If you look, it's saying arc sine of something negative, we're going to look down here. Arc cosine of something negative, we're going to look up here in quadrant 2. Arc tan of something negative, we're going to be back down here in quadrant 4. Arc cosecant of something negative, quadrant 4. And then the last two are kind of those exceptions. Because cosines in quadrant 2, we want to look for an inverse secant in quadrant 2 if it's negative, and then arc cotangent. Okay, that gets a little bit overwhelming to kind of think through. For some of us who are more visual people, I kind of want to share a little chart for you on this as well. And then I'm going to bear with me because you're kind of probably thinking, what in the heck does this mean? How are we using this? But it will make sense here in just a second, I promise. So if we are looking for an arc sine or an arc cosecant, then if the value is positive, we're going to look in quadrant 1. If it's negative, we're going to look in quadrant 4. So that's kind of how you can think about that. Okay, and then if we are looking for an arc cosine or its reciprocal, in other words, arc secant, then if it's positive, we're going to look in quadrant 1. And if it's negative, we're going to look in quadrant 2. And then we actually have to draw two for this because we want to look at the arc tangent and then our arc cotangent is separate. Yikes. I'm trying to talk and write. It's not working well. Okay, so for arc tangent, we're going to look in quadrant 1 if it's positive, quadrant 4 if it's negative. but for arc cotangent, if it's positive, we're in quadrant 1. If it's negative, we're in quadrant 2. All right, here's how we use this. I'm going to write some examples down, kind of down below here. Well, no, I'll do it up above on that next page, I think. Some other examples besides what you see there, okay? All right, so for this type of problem, these are, if you think about it, we are finding angle measures, right? So that means we are finding the inverse. So we're going to review how we do this on the calculator, but then we're going to talk about a little bit more about how we deal with finding inverses, kind of in a little bit different context, using unit circle, okay? So think about what we did here. We were working backwards. We were given the value, and we had to find what the angle measures were. Okay, so keep that in mind. All right, flip on over to page 16, and we'll kind of get started with some of that. The first thing to mention is the fact that we've got some other vocabulary to become so familiar with. Oops. If we are asked to find the arc sine of -1/2. So I want to look at these two together where we have the arc sine of 1/2 and the arc sine of -1/2. So if we're just asked to find what is the arc sine or the inverse sine of 1/2, then you're going to your unit circle. This is a positive value, so that means we're going to look in quadrant 1 for where the sine value, in other words the y, is 1/2. So where is that? What degree measure or radian measure? I'm sorry? 30 degrees. There you go. Excellent, Dina. So 30 degrees. I might ask for the angle to be written in degrees. I might ask it for radians, so you may want to practice both. Okay? So inverse sine of something positive, we go to quadrant 1 and we're looking for where that sine value is 1/2, and we're finding our angle measure. Whereas if I'm asking to find the inverse sine of a negative value, what quadrant am I going to look in? What quadrant do I have to look in for an inverse sine of something negative?
4.
Yep, we've got to look in quadrant 4 now. And if we're looking in quadrant 4, it changes what our angle measure is going to be, what our answer is. So the inverse sine of -1/2 is what?
330 degrees.
There you go, 330 degrees, or 11 pi over 6. Okay. Let's look at this arc cosine of 1, and I want to add to that, and I want to figure out what's the cosine, or the inverse cosine, I should say, of -1. So I want to look at those two questions as well. So first, the arc cosine, or the inverse cosine of +1, that means we're looking over, it's somewhere near quadrant 1. Where is the cosine value? What's the degree measure, Alex Subin, for the cosine being equal to 1? Thanks, Zach. Okay, 0 degrees. There you go. Excellent. Or 0 pi, right? Okay. Whereas if I ask you to tell me what the inverse cosine of -1 is equal to, that means we're looking in which quadrant?
2.
Yep, we've got to look in quadrant 2. And so our answer is what? For the inverse cosine of -1. I'm sorry? I heard someone say it. Yes, there you go, 180 degrees, or just pi, right? Okay, so do you see how, depending on whether the answer is positive or negative, that is helping us decide which quadrant to move to, and then where we're going to start to look for our answers. So let's look at some other examples here. Questions on any of that so far, though? Okay. All right, let's look at some more examples here. We're doing arc sine of something negative. So which quadrant should we look in? CJ, which quadrant would we look in for arc sine of something negative?
4.
4, yep, oops. Okay, so we're in quadrant 4, and we are looking for where the sine value, in other words, the y, is negative square root of 3 over 2. So where is that, CJ?
270.
Careful, look again.
Wait, you said negative square root of 3 over 2?
Yep.
300.
300, there we go. So 300 degrees or 5 pi over 3 is the same thing, right, in radians? Practice doing both the degrees and radians, I think. Okay, inverse tan, something positive. So which quadrant are we in, guys? If it's positive, we're in quadrant 1. Okay, so Maya, where is the inverse tan equal to root 3? Remember, tangent is y over x, or the numerator of the y over the numerator of the x.
60 degrees.
60 degrees, there we go. So 60 degrees or pi over 3. Beautiful. Okay. Let's look at 2 more examples here, and then we're going to look at stuff that's a little bit more complicated. All right, inverse cosine of a negative value. So which quadrant should we look in? Go back and look at your chart. Which quadrant do we look in if we're inverse cosine of something negative? Kylie, what quadrant should we look in? It's an inverse cosine of something negative though, so be careful. Which quadrant? Nope, you're flipped back too far. You should be, it's on the bottom of page 16. 16. Inverse cosine of something negative, yep. Find it in your table. You're looking on the wrong page. Okay, so we're doing an inverse cosine and we're doing something negative. There you go, quadrant 2. Okay. So in quadrant 2, we're looking for where the cosine value, in other words, the x, is negative square root of 3 over 2. So Kylie, where is that? Okay, you were just right there. You should know by now I'm not going to let you say that. Okay, we're in quadrant 2, we decided, and we're looking for where the cosine, or the x, is negative square root of 3 over 2.
So 150.
There you go, 150 degrees, or 5 pi over 6. Okay, and arctan of something negative, which quadrant, Colby? Quadrant 4, there you go, we're in quadrant 4. And, I'm sorry?
Oh, is it 270 degrees?
It's not 270, be careful, tangent, remember we have to do y over x, and we have to get negative 1.
Yeah.
So where in quadrant 4 is the x and the y value the same so that we would get positive 1?
315.
There you go, good, excellent. 315 degrees, or 7 pi over 4. Excellent. Okay. Comments, questions, thoughts? Here's where, like, you've got to know. You're looking for your x or you're looking for your y. There's a lot of little bits and pieces of information that now, if you haven't quite gotten memorized, you've got to start working on that because it's a lot of little pieces that you're having to pull together from different locations and thoughts and ideas, put it together to come up with an answer for something. Okay? All right. Let's look at what's referred to as composition of functions. So I need you to notice what's happening here. We're using multiple trig functions here and we're doing composition. The order in which we do this is important. We always work from the inside out. So what this is saying, I want you to think about this. For this particular example, this is saying find the inverse cosine of something positive. So we're finding an angle measure. If we're looking for an inverse cosine of something positive, what quadrant should we be in? 1, yes. So we're going to look in quadrant 1, and we're looking for where the cosine value is a half. So where is that? 60 degrees. Excellent. Okay, so we just found an angle measure, and now this is saying take the tangent. So we're doing the reverse operation now, right? Now we're saying now take the tangent of 60 degrees. So that means at 60 degrees, we need to do our numerator of the y over the numerator of the x. And so our answer then is that value of square root of 3 or square root of 3 over 1. Okay? All right, so I need you to think about the fact that the order for this, what we ended up with for our answer, is a value. Okay? In some instances, you're going to end up having to give a value, and others you're finding an angle measure. So this next one, our final answer is going to be an angle measure. All right, so think about steps, the order that we're going to do things here. Cosine of 2 pi over 3. So we have to figure out what that is first. So Leah, help me out with that. Cosine of 2 pi over 3. So go to your unit circle, and we're looking for where 2 pi over 3 is, and we're looking for, yep. Well, okay, I'm sorry, say that, yeah, it's at 120, but what's the value there? There you go, excellent, yes. So negative 1/2 is the value that we get, okay? And now this is saying we want to do the inverse sine of that negative 1/2. So here's why I have this little note here about watch quadrants, because we're about to have to jump quadrants, aren't we? Now we have to do the inverse sine of something negative. So what quadrant are we jumping to? Yep, we've got to jump to quadrant 4. And so Vivian, help me out with that. Now we're in quadrant 4, and we're looking for where the sine value is negative 1/2.
330 degrees.
330 degrees. Or, guys, notice something here. In the original problem, this was written in radians. So we want to write there you go. We want to write our answer in radians. So we don't want to say 330 degrees. We want to put that 11 pi over 6. So that we're using the same form. Okay? All right, questions on either of those? So notice the order in which we did the work. On the left, we ended up with a value for our final answer. On the right, we ended up with a radian measure, an angle measure for our answer. It's just dependent on the order in which you do stuff, so be careful. Okay? All right, let's look at these other two, and then we'll get to these down below that are trickier. Okay. So we are starting by taking the inverse cosine of a negative value. So what quadrant should we be in, John?
Quadrant 2.
Quadrant 2, excellent. And we're looking for where the cosine is negative 1/2. Where is that, John?
Is that 123?
It is at 120, excellent. Okay, so the inverse cosine of negative 1/2, that gives us that 120. And now we are supposed to take the cosine of 120. Alex Leary, what does that give us? Oh, careful. Cosine, which is the x at 120. Okay, there you go, negative 1/2. So guys, if you look on this one, we ended up right back where we started, right? We had this negative 1/2 to begin with. We got negative 1/2 to end. Okay, it doesn't always work out that nicely though. Okay, Talia, the cosine of 5 pi over 4, what is that equal to? Excellent. Negative square root of 2 over 2. Good. And now we are supposed to do the inverse cosine of that negative number. we gotta jump quadrants, don't we? Because to find the inverse cosine of something negative, we need to be in quadrant 2. And so if we go into quadrant 2 and we look for where the cosine value is negative root 2 over 2, you find that the answer is 3 pi over 4. Okay? All right, it's a lot to kind of absorb. I know, I get it. Questions before we look at 2 more examples? Hopefully you're kind of starting to get the hang of that. The worksheet that you're going to do for homework gives you practice with that, okay? And I'll explain a little bit about that in just a second. These last 2 examples, if you notice, it says these are more involved. So here's what I want you to notice. They don't look any different than this section right above, but if you start looking on your unit circle for the arc sine of a negative 2 over 5, you're not going to find that on your unit circle. And in this example, what does it say? An arc inverse tan of a negative 2, you're not going to find that on the unit circle. So this last type of problem, what we're going to do in order to solve is when not found on unit circle. So if you start looking at a problem and you see that it's a value that's not on the unit circle, a little alarm should go off in your head and say, okay, that's when I have to do this other thing, right? So hopefully that will help kind of refresh your memory and help you remember, okay, I gotta solve these a little bit differently. So I've even put here, if you notice, what I want you to think about is if we look at this arc sine of negative 2 over 5, what that's telling us is that if we took the sine of theta, that it would be equal to this negative 2 over 5. Okay? So we're going to have to draw a triangle and think about where this is in the coordinate plane. And we're going to draw a triangle, and we're going to use our right triangle trig that we know are SOHCAHTOA and our x's and y's and r's in order to solve this problem. Okay, so if we're taking the sine of something and it's negative, that means we are dealing with quadrant 4, right? So let's draw our triangle in quadrant 4. And we can label our sides. So our sine is going to be opposite over hypotenuse. And so we need to figure out what that other side is. So this is going to be 25 minus 4 is equal to x squared. So x is the square root of 21. And so we have our triangle, and now we need to go back to the original problem and realize what it was really asking us for is to figure out what the cotangent is. So if we want to figure out what the ratio is for the cotangent of theta, we're going to do cotangent we know is x over y, or you can think of it as adjacent over opposite. So we end up with the square root of 21 over negative 2. You can put that negative anywhere, as long as you just have a single negative. Okay, questions on that process? It's a little bit more involved. It's kind of extending our thought process a little bit, using what we already know, though, about drawing our triangles. All right, let's look at another example, and then I'll explain about the worksheet, and I'll talk to you a little bit about the project, too. Okay, on this one, if we try to find the inverse tangent of negative 2, you're not going to find that on your unit circle. So like I said, a little alarm should be going off in your head. Can't use unit circle, so we're going to have to draw a triangle, okay? Inverse tangent of something negative, actually that's in quadrant 4 also, isn't it? So let's draw our triangle again in quadrant 4. And tangent, this is kind of the ratio you want to think about there. So that means that the tangent of theta is -2/1. And so then we need to figure out what the other side is for that triangle. So we get 4 plus 1 is c squared. So this, we end up with square root of 5. And what are we doing here? We're supposed to find our cosine, our ratio for cosine. So cosine of theta, and cosine is going to be adjacent over hypotenuse, so 1 over root 5, which means root 5 over 5. Okay. All right. This last type of problem, you're not going to see on the homework tonight. We're going to practice and review with that more when we get back from break. The worksheet, if you take a look at it, and I'll get those to you in just a second, but the worksheet is just giving you practice with the inverses. So I'll point a couple of things out to you on that, okay?